is a country with extreme weather change, even though it is highest inhabited continent in the world. But flooding can happen rapidly in some regions of Australia, especially in Queensland and New South Wales. According to BOM Australia, rainfall amount in Queensland and New South Wales were above average from 2007 to 2016. Before data visualization, some meteorology knowledge that we need to know. How is rain formed? First, we need the sun. When the sun shines on the water, the heat of the sun warms the water and turns it into an invisible gas called water vapor. When the wind blows toward the low pressure, the air and water vapor will rise in the atmosphere. As the water vapor rises higher and higher, the cool air of the atmosphere causes the water vapor to turn back into tiny water droplets. These water droplets eventually gather to form clouds. Once these small water droplets are begin combined in the cloud, it will become heavy enough to descend and then fall as rain. The dataset we use in this project is Weather in Australia dataset, which contains about 10 years of daily weather observation from many locations across Australia. Based on the dataset, we would be looking for the rainfall trend across different regions in Australia from 2009 to 2017. Besides, we also want to extract information on several factors such as sunshine, temperature, humidity, cloud intensity, and wind gust speed to study their relationship with rainfall in Australia. In addition, the dataset is also used to visualize the rainfall in Australia at different times and forecast the future rainfall in Australia.
Back in 2008, Sri Sawang and the team has conducted a study to produce a classification and prediction models which use decision tree artificial neural networks and support vector machine to forecast rainfalls to provide extra input to the Thailand government on their cloud seeding operation. Feature selection is used to identify the relationship between rainfall occurrence and other weather conditions attributes such as number of clouds, cloud base height, cloud intensity, and rain coverage area. In 2013, later, Natos and the team collected meteorological data and used it to train their artificial neural networks models to build predictive model to forecast rain intensity in Athens, Greece. The model mostly concerned with the projected mean, maximum, and minimum monthly rain intensity to forecast the rain intensity and yield statistical significant level of P less than 0.01. Later in 2018, Choi and the team also developed a prediction model to predict heavy rain damage for the Seoul capital area in South Korea. This is significantly useful for the South Korea government because around 65% of all damages occurring in South Korea were due to heavy rain. Two prediction models were produced. First is to use weather data on a given day to predict whether there will be a rain damage on the same day. And the second is to use historical weather data to predict a heavy rain damage on a given day. Another sampling technique was also used to help balance the unbalanced data, and they have achieved average AUC value of 95.55%. Balamurugan and Manoj Kumar in 2019 initially conducted a study to observe the percentage of rainfall by using the traditional forecasting method, but yielded a result of around 46% to 91%. Later, they used logistic regression, decision tree, and random forest algorithms to train and predict the rainfall. 84% of accuracy was received using logistic regression, and the true positive rate was recorded at 0.95 and the root mean square error of 0.1126. Line chart is one of the most effective modes to display time series data and augmented using different colors to show a different categorical attributes. For example, trend of rainfall amount across a period of time. And bar chart is also used to show rainfall and specificity based on different Australian states. Superimpose of the trend lines on the bar graph to show the relationship between different factors that are affecting the rainfall. And the bubble chart is also used to show correlation between rainfall and sunshine across the states of Australia, with different colors representing the different states. Superimpose of the bubbles on top of a map based on their latitude and longitude. Through this, we can perceive the rainfall patterns according to geographical region. More we can see from the analysis part later.
To begin with the visualization analysis, we first visualize the heat map to observe the average sunshine across Australia from year 2009 to year 2017. In this heat map, the average hour of bright sunshine in the day is represented by color hue of orange and blue, with gradual lighter color saturation and size of box. Orange color indicate higher average sunshine duration, while blue color indicate lower average sunshine duration. Other than color, we also can observe that the sunshine duration is by size of the box. We can observe in the visualization that the highest average sunshine time is at Perth with an average sunshine time of 8.79 hours per day, followed by Perth Airport and Perth indicate in shade of orange and decreasing size of box. Locations like Williamstown, Canberra and Cobar are shaded in blue as they have lower average sunshine time per day. Then we analyze the rainfall volume in Australia. This bar chart visualizes the average rainfall volume from year 2009 to year 2017 across cities in Australia. However, the 40 over city is grouped according to Australia's state by color hue, as too many colors may make our visualization complicated and not effective. In this visualization, we notice that Queensland has exclusive rainfall amount compared to a location from the other state. We further our visualization analysis by creating a dashboard which displays more detail of rainfall information and comparison among of cities across Australia. Other than the average rainfall we visualized earlier, we also visualize the average rainfall volume by discrete month using a bar chart and the average rainfall over the continuous month using a line chart. We also transfer our data onto a map focusing on Australia region where a bubble indicates a higher average rainfall volume of the city. For example, in this dashboard, Queensland is selected and all the detail is highlighted to the city located in Queensland using orange color. After the two major visualization analyses of sunshine and rainfall, we further our analysis by looking into a relationship between both of them. Geographical visualization of both the rainfall and sunshine is visualized side by side to observe the relationship between them. At the same time, we also analyze the relationship by visualizing data into a scatter plot where color hue display a different state in Australia while bubble size indicate the average rainfall volume of the state. A weak correlation between these two variables can be observed through the relationship line drawn in the scatter plot located at the right-hand side. Until this stage, we can conclude that Queensland has the highest average rainfall among the cities in Australia, and sunshine is not the major factor that affects the rainfall due to a weak correlation. Thus, we will further our analysis on other factors focusing solely on Queensland only. My teammate Fiona will guide you through the further analysis on other factors that might affect the rainfall in Queensland, Australia.
We made some research on the internet and found that Queensland was hit by massive floods several times over the years, especially due to the season of La Nina. In February 2009, the coast of Queensland was taunted by tropical cyclone Hamish. Flooding happened in December 2010, March 2012, and the recent one happened in December 2020. Hence, we will examine and analyze on Queensland rainfall trends and its factors. In this figure, we can see how line is used as mark to encode the trend and patterns of average minimum and maximum temperature in degrees Celsius, and the average variance of the minimum and maximum temperature. The trend lines are superimposed on the average rainfall bar chart, which shows the monthly average rainfall from 2009 to 2017. As we can see, when the temperature rises, the average rainfall amount also increases. This means that there is a strong positive relationship between temperature and rainfall. In this visualization, we can observe the trend of average humidity percentage at 9 a.m. line in green color and 3 p.m. line in red color. Both lines are superimposed on the average rainfall bar chart, which shows the monthly average rainfall from 2009 to 2017. When the humidity increases, the average rainfall also increases. In contrast, when the humidity drops, rainfall decreases. We can say that humidity is another major factor that causes rainfall. This figure illustrates how line encodes the trend of average cloud intensity at 9 a.m. and 3 p.m. The trend lines are superimposed on the average rainfall bar chart, which shows the monthly average rainfall from 2009 to 2017. We can see that when the overall cloud intensity increases, the average rainfall increases as well. We can deduce that cloud intensity strongly contributes to rainfall phenomena. Another contributing factor to heavy rainfalls and causing severe flood occurrence is wind gust speed arise from storm surge. In this chart, we can see the average wind gust speed, indicated as green trend line, is superimposed on the average rainfall bar chart, which shows the monthly average rainfall from 2009 to 2017 in Queensland. Here, we can see that the average of rainfall amount will increase when the average of wind gust speed is increased. Thus, we can say that wind gust speed is one of the main factors that will influence rainfall amount. The bar chart here shows the average rainfall with different wind gust direction from 2009 to 2017. From this figure, we notice that the average rainfall amount is the highest when the wind blows from south to north, which is also called as south wind, followed by its relatively high average rainfall of its neighbor's direction, including south-southwest or SSW and east-southeast ESE. Besides that, we also observe that when the wind is blowing in between south and east, which included south-southeast, southeast, and east-southeast, are having the higher total rainfall amount resulted from monsoon season. Since New South Wales is under Queensland, which in our opinion could be vulnerable to flood disaster, thus we made a comparison between Queensland and New South Wales from 2009 to 2017 as shown in the chart here. Based on our observation, the average wind gust speed in New South Wales is slightly higher than Queensland. Clouds intensity in Queensland are rather denser than in New South Wales. In terms of humidity, both states are somehow similar, fluctuating between 40% to less than 80%. In the aspect of temperature, both states share similar wavy patterns of peaks and troughs, but Queensland's average temperature is always higher than New South Wales. Hence, in overall, New South Wales appear to have more stable average rainfalls compared to Queensland. Hence, it is less vulnerable to floods. Next, Lavinia will present on discussion and future works and conclude this presentation.
Thank you, Fiona. So based on the visuals in previous section, line chart and bar chart are very suitable for our dataset. Line chart express the trend line, while bar chart help us to perceive and allow us to compare the rainfall amount across places in Queensland accurately. Whereas bubble chart is not as good as them. Why? When bubble charts are superimposed on the map, the partition of states is blocked. Imagine if we have larger dataset and then the information will become denser where many bubbles will clump together. The label of the location may be difficult to read too. Well, to avoid this, choropleth is a good solution. But due to the limitations of Tableau database, Tableau cannot recognize most of the states in Australia. Thus, currently bubble chart is the most suitable idiom. For future work, we would like to collect more data from past 3 years to aid our study on weather in Australia. Besides, we also like to collect data related to thunderstorm and snowfall as they are valuable data for weather forecasts. Bushfire is another vital natural disaster in Australia. In the future, we would also like to work on the predictions of bushfire in Australia based on the analysis on humidity, temperature, and wind speed. Weather-related forecast is also very important for flying industry. In the future, we will also like to predict weather for airports in Australia so that pilots can get prepared for bad weather. We also want to develop a predictive model for flight delays and cancellation based on the weather data we have. In a nutshell, the data visualization helps us to find out factors influencing Australia rainfall across different locations. Based on our observations, temperature, humidity, clouds, and wind gust speed are the contributing factors to heavy rainfall and occurrence of flood in Queensland. We carry out analysis based on our observations. Moreover, we also perform rainfall prediction for Queensland based on the humidity trend. For future work, we plan to gather more data and increase the prediction accuracy. With this, I sum up the presentations. Thank you.